Hello everyone. So in this video tutorial I'm going to talk about SR latch. So this SR latch can hold a 1 bit at a time. So let me begin with this NO gate latch. So this is SR latch. S is for set and R is for reset. So here we have a NO gate. Actually it's a O gate combined with a NOT gate. So we call this one as a NO gate and another NO gate here. So I have named this NO gate as X and this NO gate as Y, and we have input R and S. We have output Q and Q bar. So one of the output of the X gate is fed as input of the Y gate. One of the output of Y gate has input as the X gate. So in this case we call this as a latch which can hold 1 bit at a time. So here I have mentioned the truth table for a NO gate. If the inputs are 0 0, the output will be 1. If the input is 1 for a NO gate, if the input is 1, definitely the output will be get as a 0. So let me start inserting values to this SR latch. So initially I would like to input S equals 0 and R equal 1. So what I'm gonna do is I'm gonna put S equals 0 here and R equal 1. So as a case 1, I have inputs S, then R, I have the output Q and Q dash or the Q prime or Q bar. So initially my S value is 0, R value is 1. Here you can see S value is 0, R value is 1. So this R value comes in this line. I don't want to consider this value because if any of the input for a NO gate, this is a NO gate, for a NO gate if any of the inputs are 1, the result will be 0. Here you can see 0. Here one of the input is 1. Here also one of the input is 1. Here also one of the input is 1. So if one input is 0, one input is 1, we don't need to consider the other input. Definitely it will be active low stage. So if I pass 1 here, for this stage if I pass 1, it comes like this. At this stage the Q will be 0. This 0 comes through this line and fed to this Y. Now here it comes another 0. Now for this Y NO gate, the inputs are 0 0. For a NO gate, if the inputs are 0 0, I can check from the truth table. If inputs are 0 0, the output is 1. So I got one answer. When set value is 0, reset value is 1, I got Q and Q bar as 0 and 1. So this is practically correct. If Q is 0, q bar is 1. It's the opposite of this one. So I got q as 0, q bar as 1. So initially what I did was I activate this R value at high stage by keeping this constant. I didn't do any change for this S value. Now what I'm gonna do is I'm gonna switch off this one. Let's check what will happen. So what I'm gonna do is I'm gonna set 0 as the set, R also 0. Now I'm gonna remove this one. I'm gonna cut. Again my new value is 0. I'm gonna cut this one. My new value is 0. Now 0 is passing to here. For the X logic gate, 0 comes to here, and we have a earlier value q bar which is 1. It will come through this line to here. It's 1. So when the inputs are 0 and 1 for a NOR gate, 0 and 1, the output will be 0. Okay, now the new value of q is 0. So this 0 is fed through this line to this Y NOR gate. Again a 0 comes here. So now what we have here, we have a input 0 from this line and another 0 from this line. So if the inputs are 0 0, the output will be 1. You can see I have changed the reset button to 0 from the initial value. Even though if I have changed the value, I got the same answer. It means it holds a memory. So let me write what I have done here. So I have changed, I haven't done anything for this S value. It's 0. R value I have make it as active low. Right? Then the answers which I get for Q and Q bar are same. Q is 0 here, I got this 0. Q bar is 1. So you can see for different inputs of R, we have the same output. Similarly, I am gonna do the changes for Y gate. Initially, I kept this Y gate constant. I didn't do any change for this Y value. It almost 0. I didn't do anything. I just changed only this reset value from 1 to 0. Right? Now I'm gonna select this Y NOR gate, and I'm gonna perform some tasks for this Y value. So as case 2, I'm gonna input S as 1 and R as 0. I'm gonna input S as 1 and R as 0. What I'm gonna do is, now initially this was now 0. I'm gonna change this one to, I'm gonna change this 0 to 1, active high stage, and I'm not gonna do any change for this one, this reset value. Okay, now let me do this one. Now what I'm gonna do is I'm going to input 1 for this S value. I'm going to cut this one and I will be inputting 1 here. This value will not change. So for a NOR gate, if input for this Y NOR gate, if the input is Y 1 and 0, I don't need to consider this 0 even. If one of the inputs are 1, then definitely the output will be 0. So I'll be writing, so here it comes 1 from this side. I don't need to consider this side, because even if the one of the inputs are 1, definitely the output will be 0 for a NOR gate. So if 1 comes here, one input is coming from here, the output which comes here will become 0. Now in this line we have 0, active low stage. That signal will pass through this line to upward and it will fed to the X gate. This 0 which came from here will move upward and fed as an input to this X gate. So now for X NOR gate, the inputs will be 0 and 0. If the inputs are 0 and 0, definitely the output will be 1. So here it has a new value 1. So when I change this S value to 1, when I keep this one reset value as 0, I got Q as 1, Q bar as 0. Now what I'm gonna do is I make this switch on, and now I'm gonna make off this switch. So what I have to do is I'm gonna mark this one as 0, active low stage. Let me see what will happen. So if 0 comes from here as an input, 0 comes as an input for this Y gate, the latest value which we have for Q is 1 now. This 1 is fed to this Y gate. Now we have here 1 and 0. If the inputs are 1 and 0, the output will be 0. So again here we will get output as 0. Inputs are 1 and 0 for this NAND gate, definitely the output will be 0, and that 0 is going to fed to the upper logic gate here. For this gate, inputs will be 0 and 0. If the inputs are 0 and 0, output will be 1. So you can see at the earlier stage we got 1 for Q, we got 0 for Q bar. Then if I change the inputs, then also I got 1 for Q, 0 for Q bar. You can see there's a similarity. Even though if I have changed, I got the similar value. In case 1 also, I have changed the inputs, I got similar values for output. So I'm gonna write what are my results now. In case 2, what I did was I make this one S as 0, R as 0. What I got was Q as 1. This Q I got as 1. Q bar, it's 0. So you can see here my inputs have been changed, 1 to 0, 0 to 0. Even though I have changed my inputs, I got the same output, so it holds the earlier bit. So let me move on to the case 3. Case 3 is a special case. So set, reset, Q, Q. In case 3, what I'm gonna do is I'm gonna mark active high stage, this S value and R value. Now what we have is, now S value we have 0, R value also we have 0. What I'm gonna do is I'm gonna make active high both set and reset. So what I'm gonna do is S is also 1, R is also 1. Let's check what will happen. So I'll use the blue color. So if I cut this one, I'll make this one as 1, input as 1. Here also I'll cut this one, I'll make this input as 1. What will happen is, if I consider this set value, we have 1 here, we have 1 here. The latest value of the other input is also 1. If 1 and 1 is fed to this NOR gate, 1 and 1 is fed to this NOR gate, result will be 0. So I will be writing a 0 here. Now the Q bar at case 3, Q bar is 0. This Q bar is fed to the upper logic gate. When it's fed to the upper logic gate, the inputs are 1 and 0. The inputs for this X logic gate will be 1 and 0, because we got 0 as the output from this Y logic gate. That 0 will be transferred to the upper logic gate. Then what we have here, 1 and 0. If 1 and 0 input to the X logic gate, we will get 0 as an output. So you can see we got 0 and 0 for Q and Q bar. It's a contradiction. If Q is 0, definitely Q bar should be the opposite of that one. It should be 1, but what we get here is it's 1, it's 0 and 0. So we got here 0 and 0. It's a contradiction. We don't use this stage. So as the next step, let me turn these both S and R into active low stage. Now what I have done in prior stage was I have activated this one and this one. Now what I'm going to do, I'm going to mark this one as 0 and this one also as 0. So initially I'm going to simplify this stage by considering the Y logic gate. Okay, let me simplify the Y logic gate first. So we will be getting 2 answers for this stage. If I consider Y logic gate, I will get 1 answer. If I consider X logic gate, I will get another answer for Q and Q bar. There are different answers. So what I'm gonna do is I'm gonna start from Y logic gate. So I have fed 0 for the Y logic gate, and the latest value of here input is 0, because we got 0 here. That's the latest value that we have. So that 0 is come through this line. Now for this Y logic gate we have 0 and 0 as the input. If we have 0 and 0 as the input, we will get Q bar as 1. 0 and 0 input, we will get Q bar as 1. If Q bar is 1, this Q bar value passes to the upper logic gate. Then in the upper logic gates, inputs are 0 and 1. If the inputs are 0 and 1, the output will be 0. Okay, when I consider this Y logic gate at first, and I'll simplify it. When I simplify this circuit considering the Y logic gate at first, I got 0 for Q, 1 for Q bar. What if I start simplification from the X logic gate? Let me tell you. Now I'm doing the same process. Now I have 0 for R. The latest value which I have for Q bar is 0. I have 0. Now that 0 is fed to here. 0 and 0 input will be 1. That 1 is fed downwards, and we have here 1, 1 and 0. If inputs are 1 and 0, we will get, if inputs are 1 and 0, we will get output as 0. So can you see these two outputs? For the same input value 0, 0, we have different outputs. Once it's 0 and 1, 1 and 0. So let me write this one. So initially, if I consider the Y logic gate, I got 0 for Q, 1 for Q bar. So when the inputs are 0 and 0, I got 0 for Q, 1 for Q bar. When I consider previous output, when I consider Q as a input for Y gate, so I get this statement while simplifying the Y gate. After that, I start from here. Then I got 1 for Q, 0 for Q bar, but it's for the same input. Now pay attention. For the same inputs, we have different outputs. So I'm not gonna we are not gonna discuss we are not gonna use these parts in this SR latch. We only use this part, case 1 and case 2. So this is the theory behind this SR latch, which holds 1 bit. So let me simulate this one, and I will be notifying the truth table for these cases, case 1, case 2 and case 3 using Logism software. Thank you all. Okay, so I'm gonna construct a SR latch actually which can hold 1 bit. So I'm gonna do this from this Logism simulate software. So let me start at first. So I need NOR gate. Actually, you can see here truth table of a NOR gate. I have included the truth table of NOR gate here and the SR latch truth table. So I will be explaining the SR latch and the all the gates using these two tables. So initially, let me construct my logic circuit. So you have to go to this gates part, this gates folder. Click that plus menu, then you will get a drop down here. From that drop down, you should take NOR gate. Click the NOR gate and paste it here. I need another NOR gate, place it here, and I need to actually reduce the inputs of these two NOR gates. So I have to double click this one, and I should go down here. Then from here I have to reduce the number of inputs as 2. Okay, I will name that NOR gate as X. Okay, for this one I double click it again. So then I will be reducing the inputs. Initially it's set default as 5, so I will be reducing it to 2. So then I will be labeling this one as Y. Okay, now my 2 gates are okay. Now I'm gonna connect these two. So what I have to do is this one is I will be fastening, and this input I will be connecting to the output of Y gate. As you can see, so this one a normal input. So this input I will be connecting to the input of X logic gates output. Okay. Okay, now my circuit is almost completed. So I'm gonna put some add pins here. So this one pin here, another pin from here, and I'm gonna connect that pin. Okay, and another display from here, another pin. Actually 2 pins. I need 2 pins here. I will be joining these two. Right, so my logic circuit is almost completed. So now I'm gonna start simulating this one. So there are like 3 cases I have mentioned in the previous sessions. So let me start this simulation. So in order to simulate, first of all I will name this input as set. So you have to double click this one, right? Sorry, this input as reset. So I will be double clicking this one, and I will be labeling from here as reset. This one as set. This output as Q, and this output as Q bar or Q prime. I will this output as Q prime, then reset set values. Now my circuit is almost complete. Now what I have to do is I'm gonna explain you the scenarios behind this SR latch which hold 1 bit. So I'll be choosing this hand icon, and then I will be selecting whether I will be checking whether this simulation is enabled or not. It's enabled. So what I'm gonna do is now I'm initially gonna practice some kind of changes for this X NOR gate, this gate, not X NOR, this NOR gate. Then So after that I'll be making some changes for this Y gate, right? So initially I'm gonna make switch on this one and then switch off again, this switch on, switch off, then at last I'm gonna make two switches switch on. At the last stage I will be switching off these two at zero. So I will be let me explain you the initial part. So at case 1 I'm gonna perform S is equal 0 and reset value is 1. So I'm gonna press this one. Let me check what will happen. If I press this one, we get Q is equal 0, Q prime is as 1. Let me show you in the table. Reset value is 1, R1 S0, R1 S0 in this column. So the output Q we should get 0 and 1. 0 and 1, it's okay. So in this, for an OR gate, let me tell you, if either one of the inputs are 1, we have two inputs. This is a one input, this is another input, this is a one input, this is another input. So either one of the two inputs are is 1, either one of the two input is 1, you will get a result 0 as the output. So we have 1 0 here. You can see because of this 1 we get a 0 here. We have 1 0 here. Because of this 1 we will get a 0 here. Because of this 1 we will get a 0 here. But we, in this first case, we don't have any 1. We have 0 0. Because of that we will get a active high stage at the X. It means the output. Alright. So let me explain you this scenario. Initially what I did was I may switch on, make it as active high, this stage. So this one will pass us through to the here, right? We don't need to consider about this input, because by assuming for a NOR gate, if either one of the inputs is 1, the output will be a 0. So if now here we have 1, the output will be 0. So that's 0. Now we got Q as 0, right? Can see Q as 0. Now this Q0 will fed to the input as this Y gate. So now we have 0 here, another 0 here. Set value is almost 0. So we have 0 0 here. That 0 0 output will be a, you can see for NOR gate 0 0 output will be 1, right? So we got 0 and 1. R equal 1, S equal 0, R equal 1. This stage R equal 1, you can see here R equal 1, S equal 0. We get Q as 0. The opposite of Q is Q prime, we will get as 1. That thing is correct. Now let me switch off this one. Observe the Q and Q prime. So I will give you a hint. The Q and Q prime won't change. Let me switch off. Even if I switch off this one, make as active low, the Q and Q prime will not be changed, right? See, you can see here. Okay, now I have switched off. Even though if I have switched off these two, Q and Q prime are the same, right? So now input is 0 0. Remember, the Q and Q prime is memory as before. It means it didn't change. It was as the earlier one. Q is 0, Q bar is 1. You can see. Now I have finished my simulation for this one. Also, let me explain you what has happened in here. So if I input a 0 for this one, we have a prior value 1 here. In prior, we had 1 here. That 1 will be fed as an input to here. If either one of the input is 1, the output will be a 0. Then here we got a 0. Because of that, we have 1 here. We got 1 output from here. Then here we will get the output as 0. That 0 will fed for this Y gate as here 0, here 0. If two zeros are input as a Y for this Y gate, the output will be a 1. You can see it from here. So that's how this 2 didn't get changed. So it holds a memory. Actually, it holds this prior value, this Q prime, right? So that's how the bits passes through these logic gates. So I have finished now this some simulation for this X gate. Now let me start with this Y gate. Actually what I'm gonna do is now I'm gonna set this value as 1. I mark this set value as active high. So let me switch on this one. If I switch on this one, we will get Q as 1, Q by 0. So R0 S1, R0 S1, R0 is this one, S1 is this row. We should get output Q as 1. Okay, you can see Q is there in the, it's 1 here, and Q by 0, you can see it's also correct, right? Let me explain you the scenario here. So we will be feeding 1 here. I don't need to consider about the other input. Even if one of the input is 1 for a NOR gate, the output will be a 0. So Q prime will be 0. That 0 will pass us to this gate. Then if now reset value is 0, here also we have 0. If 0 0 is the input for this one, the output will be 1. 0 0 input, output will be 1. So that's how we got this 1 and 0. So let me change this value. Before changing, I'll give you a hint. Just pay attention to these two. If I make switch off this one, these two will not get changed, right? So I'm gonna switch off. Okay, now I have switched off. I have changed the inputs, but these two remains the same. See, R equals 0, S is equal 0. These two remain same as the prior input. So when 0 0 are inputs, the memory is as before. Q and Q prime are same. It didn't change. It has the previous value. Previous value is this one, 1 and 0. You can see. So let me explain you this scenario. If I input 0 from here, we had 1 from this prior output. If either one of the outputs input of for this Y gate is 1, the output will be a 0. Then this 0 will be fed up to here, right? If 0 0 is an input, output will be a 1. 0 0 is an input, output will be 1. So that's how this scenario works actually. This SR latch work. So in these two instances, they hold a 1 bit. So now let me explain the case 3 actually. Now I'm gonna make this 2 as active high. Initially what I did was I make switch on, switch off this one, then again this switch on, switch off this one. So next I'm gonna switch on both two. I'm gonna switch on this one and also this one, right? If I switch on these two, what will happen is let me explain you, the output will be 0 and 0. It's a contradiction. If Q is 0, definitely the Q prime should be 1, opposite of this one. So here we get 0 and 0. It's a contradiction. We don't talk about this case in this SR flip-flop. We don't use this one. So you can see when the both inputs are active high, yeah, it is not in use. Alright, so let me explain you the scenario. If 1 comes here, definitely the output will be a 0. So this 0 is fed to here. If 1 and 0 is the input, definitely the output will be a 0. So we got Q as 0, Q prime as also 0. It's a contradiction. So we don't use this stage for this SR latch. So let me switch off both cases now. Right? So initially I switched off this reset value, then I switched off this one. What happened? So we got 1 here, 0 here. In this case, I'm gonna show you for these two reset and set values. We have 0 here, 0 here. For these two inputs 0 0, we will get 1 here, 0 here, and I'm gonna show you there will be another one, another value. When the inputs are 0 0, we will get 0 here, 1 as the Q prime. We will get now we have here 1 as Q, Q bar as 0. If I tell it simply, here we got 1 0, and for the same inputs we will get 0 1 here. I will show you that. So now initially let me explain how this one had happened. Actually here 0 comes from here, this one comes from here, the previous value. If 1 is an input, definitely the output will be a 0. Then this will be fed to here, right? 0 0 input, you will get a 1 as output. Okay, we have 1 and 0 here. So what I did was, initially there was a 1 here, there was a 1 here. I make this one as 0 and make this one as 0. Then I'll check the output. I got this as like this. So let me show you. For the same 0 0 input, you will get 1 and 0 here, 0 and 1 here. Okay. So I will show you how we will get different outputs for the same input 0 0. So my prior stage was it's 1 here and 1 here. So initially to get 1 here and 0 here, what I did was I switch off this one at first, right? At this stage, in order to get the first one, I switch off this reset value first and then I switch off this one to get a 0 0 combination. Now what I'm gonna do is I'm gonna switch off this one first and this one as the second. So you can see for the 0 0 input, earlier we got 1 and 0, now we have 0 and 1. Earlier stage for 0 0 input, we had 1 here and 0 here. Now for the same inputs, we have 0 and 1 here, because I started calculating this latch, actually no gate, from this one. I started calculating from this one. So let me explain you how did this happen. So if this 0 comes from here and this 0 is fed to here. If inputs are 0 0, the output will be 1. Inputs are 0 0, output will be 1 for an OR gate. So that one will pass up to here. If 1 is an input, definitely we don't need to select this one. By assuming it will be a 0. So that's how this simulation works. Actually we don't use this 1 stage for our purposes. Actually we use these 3 stages for hold a bit. So that's how this 1-bit SR latch works. Actually thank you for listening. So we'll be moving into next tutorial with some interesting facts. So thank you.